Welcome you all. Today we are going to discuss a problem called traveling salesman problem from the by solving an approximation algorithms. Let's move on to the problem. So approximation algorithms for this traveling salesman problem. There are three types of algorithm for traveling salesman problem. One is nearest neighbor problem, another one is multi-heuristics problem, another one is twice around the tree algorithm. So using any of this algorithm, we can solve this traveling salesman problem. So today we are going to solve this using an approximation algorithm called multi-fragment heuristic algorithm of traveling salesman problem. So these are the steps for this multi-fragment heuristics algorithm. First, we need to sort the edges in the increasing order of their weights and initialize a set of two edges to be constructed as an empty set. Next, step 2, we have to repeat this step n times, where n is the number of cities in the instance being involved, and add the next edge on the sorted edge list to the set of two edges and provide this addition, so that this addition of this new edges should not create a cycle less than n. Okay, so vertex of degree 3, otherwise skip the edge. So step 3, return the set of two edges. So here I have taken a graph of 4 edges. So I am going to sort it in an ascending order. So AB is 1, DC is also 1, next is BC is 2, next DB is or BD is 3, and AC is 3, and next finally DA is 6. So I have two edges as empty, that is represented as 5. Now I have to add the smallest edge in the two edge, that is AB. So I am adding it. So it is not forming a cycle. Next I am adding DC. I am adding it, not forming a cycle. So next I am adding a BC. So it is also not forming a cycle. So when I am intended to add this AC, it is forming a cycle of length 3 is formed. Next BD I am adding, it is also forming a cycle of length. So I am just neglecting that, and I am adding DA to the two edges, so it is not forming a cycle. So whenever I am adding this edges one after the other in an increasing order, so that I am checking once adding a new cycle, it is not forming a cycle of 3 or not. What is this 3? See here, if I see here, see here A, B, C. So it is forming a cycle among the three edges. So the length is 3. Here also it is forming a cycle among the 3 edges. So it is also should be neglected. Finally, I am adding AD. It is not forming any cycle of. So it is forming a cycle, but it is of length 4. So I am just accepting that it should not form a cycle less than n. So what is n? The number of vertices. So it is here. It is 4. So when it is 4, it should not form a cycle of 3. So this is an simple way of finding a minimum spanning tree using a multi-heuristics algorithm. Hope you find it useful. So now we see here the total cost is 1 plus 2 plus 1 plus 6 is equal to 10. I cannot say as this is the best minimum spanning tree because this is an approximation algorithm. It is an approximate algorithm. So see here, but the shortest tour length is 8. But multi-heuristics algorithm, it is giving a cost as 10. So solution obtained is approximate algorithm. So that's what I said. It is not a best solution. It is an approximate solution for the given problem. Hope you find it useful. Thank you.